I picked the problems to do as examples because it's probably going to be similar to that on the test. Not my lesson notes. So like yesterday's, you're going to have a problem like one on yesterday's, finding that your tangent line within a certain amount of error. It is hard. Remember some of it's partner. I don't remember which part's with which. I think that's partner. And we're going to have some of this on the differentials on the test. It'll give you a little practice test to work on for review. So I'll get that ready for tomorrow. So dy and dx are called differentials. If I do this, my slope is dy over dx, right? You can separate that derivative operator. It has another meaning. It's the change in y over the change in x, and that's equal to f prime of x. Okay? So that's my slope there. There's my slope of my tangent line. Well, if I'm thinking of this as a slope, it's a ratio of rise over run. This little segment, I'll try to keep it the same color. This little segment on the tangent line is dy. It is not the actual change in the y. It's the change in the y on the tangent line. Hey, guys? This is the change in the y, not of the function, but of the tangent line. This is the actual change in the y values. This is y1 minus y2 of the actual function. So I can use differentials to help me estimate. Now, back in the day, we didn't have calculators. So that's the reason why we did this. We wanted to estimate. James, where's your packet? Where's your packet? You have your packet out. So that yes, we did get it yesterday. So what's the slope of the tangent line? I think I probably have it hidden. Oh, no, I don't. Oh, there it is. No, I want to do this. There it is. Solve this equation for dy. So if you solve for dy, the change on the tangent line is equal to the derivative of the function times the change along the x. So this, now, is dx and delta x, are those the same things? Right here. Yes. Dx does equal delta x, but dy does not. Dy is approximately delta y, which is how your calculator works. It'll find dy because it knows how to do that. That's easy because that's linear. So this is the change along the tangent line. So I highly recommend you take notes, since I doubt you go back and look at the videos, etc. Okay? And dx and delta x, those are the same things. So how do I use this? What do the homework problems look like? I'm just doing this for approximations, that's all. I can find errors and areas and things like that. Are we ready to switch pages?
I'm ready.
And let me write down, delta y is the actual change in the function. So in the days when we didn't have calculators, this was an easy way to estimate some errors. We have calculators now, but even then, it's still easier to do this, and it's pretty accurate, actually, as long as your delta x's are small. Okay, and that page number will not be correct. But let's look at this problem. It's y equals the square root of x. Okay, David, question? So I'm going to graph that, and we should know what that looks like. Now, this is a function that does not increase very fast. So this is a function that works nicely with differentials, because things aren't going to change much. So here's my square root of x. And if you don't pay attention, I think you'll get lost, because there are a lot of little things going on. And it says find the differentials dy. Well, if you don't know what to do, let's find the derivative of that function. So y equals x to the 1/2. That's the only way I know how to do rational exponents. I have to make them rational. So dy dx is equal to 1/2 x to the negative 1/2. Right? So solving for dy is equal to, let's clean this up. It's 2. This negative exponent puts everything in the denominator, and it's still a square root of x. And I'm going to multiply by dx. That's going to give me the change along the tangent line. This is always an AP question. I see it quite often on the exam. So I want to find dy and delta y. Well, let's look at the picture at x equals 1. Hopefully my picture's okay. So here at x equals 1, I'm going to look at the tangent line. And we'll make this a big delta x so you can see it. But there's delta x, which is equal to dx. What's this distance? Dy or delta y? It's the change on the y along the tangent line. So that's the dy. The delta y is the actual change in the function. So you started at 1 and you get up to whatever that value is. That's delta y. Do you see the difference between those two? But that's important to keep those straight. Delta y is the actual change in the y value. I'll need a calculator to find that. But dy is just using the tangent line. I don't need a calculator, I don't think. So I want to find my dy and delta y starting at 1, and my delta x is equal to 1. So delta x equals 1. So where am I going to be over here on my x's? 2. Okay, it's not drawn to scale. It's okay. I hope it's okay. Well, what's dy? Dy is just this little distance right here. So dy equals 1 over 2. And what x value do I want to put in, though? I don't want to put in 2 because I don't know what the square root of 2 is. I want to put in the dy that started at x equals 1. So it's not going to be right. It'll be close, but it's not going to be right. I'm going to put in 1 there. And what's delta x then? It's 1. Well, I know what that is. What's dy equal to? 1/2. Or you guys prefer decimals. Okay. And then I want to find what delta y is. What is delta y? This is no calculus. Whoops. Delta y is just the change in the y values. So delta y is equal to f of 2 minus f of 1. So that's the square root of 2 minus the square root of 1. Do you guys know what the square root of 2 is? 4, right? Minus 1. You can use a calculator. You'd have to use a calculator. This is how they did it without the calculator, so. Okay, what happens when I subtract it? I get 0.414. How does that compare to this? It's pretty close. And, by the way, is this an overestimate or underestimate? Look at your picture. And that's what they're going to ask you on the exam. Is it an overestimate? And you look at your picture. Don't make it hard. Because I'm going to write the equation of the line starting at x equals 1. I want this line. So this is the change in y along this line. I could write the equation of the line. That's another way to do this problem. Right. It's wherever the tangent line is. It has to do with the concavity, yes. Mm-hmm. I always draw the picture. I don't memorize it. I don't know. I know. I got to be careful because there are other things where it doesn't work that way. But sometimes it's increasing, decreasing. No, this is just finding. I want to find out. I want to estimate what the square root of 2 is, for instance. They don't sketch a diagram. I did that. So what would this? If let's say I did this. What is the square root of 2? Approximately, using my tangent line. Okay, I don't have a calculator. I don't remember. It's 1.414. What is the square root of 2? Well, this is 2 square root of 2. Right here on the curve. Where is the curve? Right there, right? So using this, how could I get the square root of 2? What is this? How long is this segment? That's 1. So this would be 1 plus this little estimate. It's not exact. It's an estimate. So it's approximately 1.5. What's the square root of 2? It's 1.4. It's delta x very small. No. If I made delta x a tenth, it'd be a lot nicer. It'd be a lot closer. But then I need another I need a calculator again. This was just doing an easy thing. So you have some problems that ask you to do that. Find your differential dy. Find delta y and dy. Delta y is the actual change in the function. You may need a calculator to do that. Focus it at x equals 1, and then they tell you how long delta x is going to be. And there's my diagram. Ready? How do we use this? I don't know if this is probably not exactly either. The author changed things, but this is a circular disc. And I want to find the error in the measuring of it. If you're a machinist, you're building machine parts, you have to have a certain tolerance. Otherwise, it's not going to work. Okay, so there's my circular disc. And the radius is 24. I can't do it without a picture. What's the maximum area of the measurement? Oh, and the maximum error in the measurement of the radius is 0.2. So you could have, the biggest radius you can have is 24 plus 0.2 centimeters, or 24 minus 0.2 centimeters. If your radius is bigger than that or smaller than that, this part is not going to work in the machine that you're building it for. And it says use differentials, not area formula, to estimate the maximum error in the calculated area of the disk. Now we can do this without differentials, and maybe we should do both. What is the area of the disk? Pi r squared. That's right.
So, what? Pi around
Pi r round.
square.
Pi's aren't square. Yeah, but you won't forget your formula, will you? Okay. So we could find the actual error. Okay, to find the error in the area, we would find A of 24.2 minus A of 24. Now I can do A of 24 without a calculator because I know what 24 squared is. Does anybody know what it is?
What is it?
576.
You probably told us it's not
No, because when I was in 6th grade, there aren't many things I remember about my past, but in 6th grade, we had to memorize all the perfect squares from 1 to 25. So I had to know them all because we didn't have calculators. Not until I was a junior in college did we have calculators. So imagine doing this class without a calculator.
What's 18?
324? Okay. Yeah, there's some I'm not great with, but anyway, because I don't use them that often. But you could do that, and you do pi, and you do 24.2 squared minus pi 24 squared, and you could get an answer. And that will be the exact answer. But that's not what I'm asking you to do. That's just the change in A. That's all that is. Because when you do this on the test, and you give me the change in A like this, I'm going to mark it wrong. So I want you to make sure that you understand the difference. I want to use differentials, which is a lot easier. If A is equal to pi r squared, what's dA? Now, can we just go right to differential form? We have to have differentials for integration. What's the derivative of this? 2 what? Pi r times dr. Will you recognize that? Circumference. The derivative of the area is the circumference. That's kind of cool. Okay, so what's r here? R is 24. What's delta r, or dr? What's my error, my 0.6? Watch and be careful with this when you do the problems. I think that the author likes to mix up the units, so he'll have meters and centimeters, so make sure you watch your units. So it's 2 pi, which messes you up, but r is 24, dr is 0.2, and if I do 2 times 2 times 24, forgetting the decimal, that's what? 96. 96 pi, but I got to count back 1. So it's 9.6 pi. So if I wanted to estimate it, this is close to 10, that's close to 3, close to 30. You guys have your calculators out? Take me a second to get mine out. How big is it? Because this is an estimate. It says use differentials to estimate. 30.16? Well, what is the actual answer? Now I can factor out a pi. I don't know what 24.2 squared is. Anybody want to tell me what this one is? Who's got a calculator? You love your calculators. Is it easy to mess this one up? Which was easier? If you're going to use a calculator, which is easier calculation to do with a calculator? The dA or the delta A? Okay, what is this? 30.28. By the way, that takes longer. If I'm a machinist, it's probably close. I don't know how well they can tool those parts. I have friends that are machinists. And yeah, they do. They throw things away because they don't work. Yeah.
Yes, he is Peter.
I don't know. But yeah, most of the parents probably are some sort of engineer. That's not a bad estimate. So on the test, you are going to follow the directions. You will get 0 points here, and you will get full points here. Because we're just trying to estimate. And I'm testing that, directly. Now, it says, what's the relative error? So what do I have? That's the error, right? 30.16 divided by the actual error, the actual area, which was, it was pi r squared, pi times 24, right? So 30.6, or actually I could leave it. Let's leave it. Does that help? Maybe not. I don't care. Square. Yes. That's centimeter squared, this is centimeter squared, and this will be 576 pi. What does that give me as a decimal? Come on. Somebody want to divide that out for me?
Okay.
Watch how you put it in, because when you put this into your calculator, you're going to have to do this. Divided by 576 pi. You're going to have those parentheses there.
0.01666.
It's 0.166 or as a percent. You guys know how to change any number to a percent? You multiply by 100%. Okay, let's start again. 0.0166. Okay, to change that to a percent, any number, I don't care what number it is, change it to a percent, you multiply by 100%. Because what number is 100%? It's 1. So then you associate these guys, the 100 just moves the decimal 2 places, so it's 1.66%. It's just a nice little thing to do it, and I learned it in the Sect book. I always knew how to do percents. But this always works. I don't care if I want to do 2/3, change to a percent, you multiply by 100%. It'll always work.
So much fun.
And I think that's it. So I don't know if you have questions on homework that you'd like me to look at. Or if you just need some time to work. Okay, but then you need to work. Details. Saving those for the chain roll. Rachel. Okay. What?
I think I got.
Oh. What's happening next week? Thanksgiving. Yes?
Thursday. God. Oh my God.
Okay. Okay. Okay, you guys? When you take the turkey out of the oven, the temperature is 185 degrees. Okay? Shh. You put it at room temperature. Because when you take it out of the oven, it's too hot to eat. Just let it cool. After 10 minutes, the temperature is 172 degrees. And after 20 minutes, whoopsie, the temperature has now dropped to 160 degrees. Use a linear approximation to predict the temperature of the oven after half an hour. So I want to know what T equals 30. So maybe we should plot some points, because I'd like to see what this might look like. Now we could put it on our calculator. I want to see a nice, accurate picture. I don't know how well I'm gonna do this. You just have to understand the question. Okay, so at 0, we're at 185. And is the room temperature important? Not for the linear approximation. Hey, you guys. Shh. You guys. It's Newton's law of cooling.
Well,
If you to do this, you're going to be looking at logs and exponentials. So it's, the 75 would be important there, but we're only going to estimate this with lines. I don't want to use a logarithm or an exponential. At t equals 10, I'm at 172. The question is, I don't know which way it's looking. At t equals 20, I'm at 160. That's 172, and this is 160. So it's coming down, but I don't know, is it concave up or concave down? I think it's concave up. Well, one way we could find out. We can't. We don't have the function. We could do a regression. So the question is 30. So what's it going to be at 30? So we'll do the tangent line. Where would you like to do the tangent line? 10? No. So you're just using this to approximate it. Obviously not drawing to scale. I'll put a little break in my graph there. You're going to have to get slope someplace. It doesn't matter. Want to do 20? Cheat. Okay, so just write the equation on the line. 20 is what? So you're going to have to get the slope there. What slope would you like to use? Probably the slope between these two guys. So it's 172 minus 160 over 10 minus 20. Why is it negative? It's cooling down. So that's what? 12 over negative 8. So it's y minus. I know, I've been doing that all day. Don't ask me why I get 8. It's got to be, no. It's 12. Want to do it again, but okay, it's negative. So it's y minus 160. Actually, let's not use y because it's not y. It's my temperature. So t minus 160 equals my slope, and it's x minus 20. So now I'm not gonna multiply all that out. It's 160. And we could reduce that if we want, but maybe it's easier to work with tenths, actually. And 30 minus 20 is what? Guys, 30 minus 20 is? So that cancels. So it looks like it's about 160 minus 12. Is that what it says in the back of the book? Does Bob agree? Where did the 30? It says a half hour later. I'm assuming it's half hour after it's been removed from the oven, not a half hour from there.
Would this stuff just like Mr. Course or just
No, this would be a semester class. We wouldn't be reviewing the AB, and you'd have vectors.
Hey, question. Since you just said that you wouldn't have vectors, you never taught us vectors, right?
No, not the vectors, your math vectors, not the physics vectors. You have physics vectors.
No, but like on our quiz, there were vectors.
No, it's just the derivative in the x direction and the derivative in the y direction. It's on the exam. But the other vector stuff is writing equations of lines in vector form. And we could do that after the AP exam, and it would be to your benefit, but you guys never want to do it. Okay. You see, I just used that. Is this an overestimate or underestimate? Look at my picture, assuming it's under. Okay, are there other questions or just work time? Oh, my voice is kind of tired out. No naps. We have a test coming up.